Video we're able to load out of the iris data set, which has to do with that of the flower, and we're able to make use of logistic regression to actually fit the model, to train the model, and to make predictions. And that we're able to the logistic regression actually perform really well. We're able to get 100%. So in this video, what we're basically going to look at is that of decision tree classifier, and that of decision tree regressor. So these two guys are basically the classification base and that of the regression base, and they fall under that of the true sub module on that of the Scikit-Learn. So how does this decision tree actually works in general? They can make use of the classifier. Decision tree classifier are for classification problem, while that of the decision tree regressor are for regression problem. When I mean regression, it's more like that of the linear regression, because that's more like the one of the regression model we have actually used. And this of the logistic is actually that of the classification based model. Let me actually get this out. So how does this decision tree made? The way decision tree actually works, it makes use of what is actually called tree based type of decision, meaning that the decision is actually make uses of is that more like that of the tree base. I have a data that we can use to actually explain how this decision tree actually works. So on how to actually import it. So first of all, let's actually import this of our decision tree. So this place is getting a little bit crowded. Okay, let's actually leave it. So we can say from our Scikit-Learn, which is our Scikit-Learn tree. So we want to import our decision tree classifier. We also want to import the data of the decision tree regressor, because we are going to make use of these two guys to solve two different problems. So let's actually go down here. So this is actually, as of now, I say on logistic regression. So this is the image that I want us to actually make. This image is not actually that clear. So this is how decision tree actually make decision. It builds a tree from that of the root. So when it builds a tree, let's assume that the first thing it has is the age. Let's assume that the age was the base. So it's going to ask some question. Then anyone that actually meets this particular category, maybe this particular answer, maybe yes or no, will go to the one side, another one will go to the other side. So that's basically how this tree works. Let's assume that age is greater than, if the age is greater than 30, yes or no. If it's yes, to go to have other question is going to ask. If it's no, it will go to the other question. Let's assume this is the root of the beginning of the first tree, the first question, or the root of the question. So is age greater than 30? I can see this point, he said yes. So has a job? Yes, no. Pick one. If he has a job, buy. Let's say this is actually more like if you want to buy something from a store. So let's assume age 30. This is how decision tree actually makes its own decision. The mathematical formula that decision tree is actually similar to those formula that those of the ensemble models actually make use of. Those of the boosting model, those of the either booster, those of the gradient boosting, SGB boosting. But these guys are on a different level. But this decision tree is more like the weakest tree-based model out there. So it just built a single tree to actually use to make decisions. So that I can see this as me. This is a normal single tree that is built, and then this is how it makes easy to make decision. This example is age greater than that of the 30. Like I said, if he now is going to look for the next, remember that these are features that is going to use to know, okay, pointing to that of the target. Actually, these are features. Age, let's assume we have the column that has the age. Maybe the other one has other stuff. So is age greater than 30? If it's yes, has a job, yes, or no. If it's no, it's no. It's going to be saying maybe. If it's yes, it's going to say maybe buy or kind of stuff. If it's no, it's going to ask a student, is that person actually a student? No, if it's not that, it's going to go to that of the yes. If it's not, it's going to go to that of the no. So each of the is trying to go through each of the features by building tree with each of the features. It's going to ask questions to know how they all map to that of the target. So this is just basically the simplest ideology on how this decision tree actually works. So decision tree tend to have that of the classifier and that of the regression, like how we actually imported earlier, as you can see here, decision tree classifier and that of decision tree regressor. To basically use that of the classifier is basically simple, since we have actually loaded this our data. So another thing I want us to make use of our old data that we have here. I don't want us to make use of this of the new data that we have, this of the iris data, so I'm going to get rid of it. So I'm going to actually tweak these ages that we have here, the ages and the salary. So if I leave it like this, it's still going to get that of the 100% that we actually set for that. Actually, the same thing that logistic regression actually got. Remember that this is data we use for our logistic regression program. This is more like a linear type of program. Our purchase was our target, and our input features were this of the age and salary. And remember, one thing you should know is that in real life scenario, these data can be really much huge and filled up with noises and uncertainties on that of the data. So don't expect real life data to be something like this, or maybe something like this of the load iris. These are simple data set that maybe arbitrary data set that is easier for modern models to actually predict. So remember, to actually make use of this of the decision tree, you can also see that of the decision tree classifier, because they are basically have similar stuff with all the classifier tend to have similar evaluation for them. So have the accuracy score, the confusion matrix, and that of the classification report. So they are just basically saying we set the test to be 0.2 for testing, and for the training that of the 80%. So that's just basically going to give us only two data, so I can say 2 rows of data for testing. From one we'll look at this is actually 1, 2, 3, 4, 5, 6, 7, 8. 0.2 times 8 should definitely give you somewhere around 2 rows of data. So I think that actually settles it. So to make it of that of the decision tree classifier, simple as this decision tree class. Remember the way he built his tree, he make decisions by making use of that of the tree method. So just build one tree and then ask series of questions to know how he got to that of the to a particular target. So the building of this tree can actually, for a large amount of data set, can actually become a little bit slow compared to some other models out there, because this tree it builds a series of questions, can make it to be slow sometimes, but this is a small data set, so we shouldn't have any problem. So everything looks good. The data, this is where we turn data to data frame, and then we selected our features and our target, which our target was this of the data purchase. Remember, you can all these variable and music, and decide to make use of any one of your choice. It's name must use these guys. I'll have the model decision tree classifier, and they will fit the model to our data, so you can actually learn some patterns on this of our data. Then we'll have the S test is what we are trying to predict. Where we make use of this S train, Y train, S test, Y test. The test, the model I've never seen that of the test, so we try to predict that of the test, S test, to actually know what is actually predicted, the future values, the new data will actually give it. What did it predict on it? How accurate was it? So that's where we came here to evaluate something that this model evaluated the result that this model was actually given up by checking that of the accuracy score, confusion matches, and this of the classification report. So these are some of the things we actually check. So let's actually run it to see our output. As we can see right here, that we tend to have that of the almost the same thing that we have for that of linear regression, which is accuracy score 100%, confusion matrix almost basically the same thing, and that's of the classification report. This classification report, like I said, is really important. So let's actually tweak the data, because when we did for that of logistic regression, we did actually tweak the data. So let's assume we set it to something like 11,000 and set this to maybe something like 38,000, and maybe set something like maybe 6,000. Let's actually mess things up right now. So let's actually see whether it's able to predict or get the accuracy of 100% again, because the reason why I was able to get 100%, basically, like I explained, out of the logistic regression, was because this data that we have here is a linear type of data. The features and the target is linearly. The increase in the feature makes that increase tend to be that of the increase in that of the target. So the x, as s increases, y increases. So I don't think there's no model out there that will, even the linear regression can feed this data almost like 100%. But now we've actually made things even messed up things. Let's actually see how this is now going to be able to fit our data, and then after that, what we are going to set for that of the regression, we are going to make use of the similar linear regression. Remember, when we make use of linear regression, at a particular point it performed poorly here, which when we set some other stuff. So we are going to use the same ideology to build for that of the decision tree regressor based models to actually see how well it's going to perform over that of the linear regression. So even when we tweak the data really much a little bit, we are able to get the accuracy score to still be 100%. You can see that this decision tree tend to be really performing really well. So if you was see that of the logistic regression, let's actually try for that of the logistic regression. Let's actually see whether how well is you see going to that should be logistic regression. Let's whether logistic regression is able to get that of the 100%. Also, like how decision tree, even if data was actually being tweaked a little bit. Let's actually see that. We're able to make use of that of the logistic regression. Logistic regression also performed really well like that to what we actually got earlier. So I can see that both decision tree and logistic regression actually perform really well, because number one, because this data is actually small and there just few changes they're able to see fit perfectly. If we want to draw the graph, we can see that what we predicted is going to be exactly what was the data that was being passing. So for that of the decision tree regressor, we can actually make use of this data to actually do that. So let me silence almost, this is actually for regression, so we can basically say do the same thing. To make use of regressor or decision tree regressor, let me comment this guy out. Let me just comment it. We are going to use the script we use for our decision tree, so we don't need to actually start from our first to write everything down again. So this was it. I think everything is settled down here. So for that, instead of linear regression, it's going to be our decision tree regressor, because this is a regression program. Remember that our target was this salary and the salary colon. We have the 30,000. Remember we tweaked it in that video, which was 5,000, and then this was 50,000. So when we did that, the linear regression was not actually performing well. What we predicted versus what was okay. Let's also print this. Let's see how well the decision tree regressor is not able to predict the new data that we have, because for that of the linear regression, it was only predicted one exactly, but while the other it got to one extra closely predictable, but other ones we didn't actually predict it very well. So let's actually see how well this decision tree regressor is going to perform over to that of the linear regression. Let's actually see that. I remember what we actually did there. We're going to print the graph out. The graph, the first is going to be a scatter plot of that of the PLT, the scatter of the data frame that we're actually passing, which is this of the DF worked here, and the scatter. This was actually the initial data that we actually used for the training of our model. Remember here we didn't actually make use of that of the train test split, because there's nothing to actually split here, because this is just only 5 rows of data. I don't think there's anything to split here. It's too small for splitting. And then for this is what was actually being predicted. You can see this of our Y predict was what was actually being predicted by this of the model, which in our case now is going to be this of decision tree. This is our decision tree. This is the output that is going to get, which is actually this of the y pred, and then this of the y pred here is now going to be passed in, and the graph is now going to be plotted. When we look at this, we're looking at everything looks good. It's really looking as if our model was able to classify everything correctly. Our decision tree was able to classify everything. The mean squared error and the mean average error and the R2 score, they were can see they were all 0 for that of the mean square error, mean absolute error. And this of our R2 score signified that our model was able to look at the variation that happened on our data, was able to read it 100% accurately. And when we look at the fitting, remember that this red dot was actually that of the main, I can say the data that was being passed into. Okay, let's look at this data that was being passed into, and this line that we had here was actually for what decision tree regressor actually predicted. And when we look at this, predicted it 100%. We can see the line actually perfectly fits that of those of the input data that we actually sent it. You can see that the regression, the way we look at the decision tree regressor actually predicted this 100%. You can see the difference between that of the linear regression and that of the decision tree regressor. Decision tree regression is far more powerful to that of the common linear regression that we actually use there. So we can actually try to transform back this of our linear regression to actually see how poorly the linear regression compared to our decision tree based model. Okay, let's actually get this out. So as we can see, make use of this of our linear regression. You can see that linear regression was able to fit only one data. Like when I mean only one, we was able to fit only one. We was able to predict only one. Can say only one data point correctly, only for the last one. But we can see this is the line of the linear regression. How was it able to predict all the values correctly? Was able to predict only one. But when we do for that of the decision tree regressor, you can see it was perfectly able to fit each of this line completely. Linear regression performed extremely poorly compared to that of the decision tree regressor. So let's say decision tree, that was decision tree regressor. Let's actually try to run this decision tree. When we look at the output of this of the decision tree, we have that this of the MS is 0.2. Remember that the lower the value, the more accurate your model is. We have this of the which is mean absolute error. You can see that we'll get 0.00 for that of the decision tree regressor. But when it comes to this of the linear regression, you can see that the values are large, which signify that our model is actually performing poorly. But when we look at this R2 score, which is actually trying to tell us that the model actually for that of the decision tree regressor, R2 score means that the model was able to understand the variation that is happening on our data 100% accurately. When you come to this of the, because 1 signifies 100%, and for this of the, when it comes to that of the linear regression, we're having 0.54, which is actually like 50.4, or can say 50%. The model was able to read the variation that is happening on your can say on your data. It's actually more like how to score. You can just think of it more like the accuracy score, but don't look at it, but just have the idea of it. So the decision tree regressor was able to predict it accurately. We can also run the script to actually see the line and how the line was actually able to draw perfectly on our data. Remember that this is why it was able to do this. Was because our data was actually small, so it was able to draw a perfect line. But you can see how the difference between this of the decision tree regressor and this of the linear regression, because this linear regression is a simple regression. Okay, let's actually get this linear regression is a simple model you can actually use to actually train your machine learning or your data. For this, our decision tree regressor is far more superior to that of the linear regression, because when we see the graph of the linear regression and graph of decision tree, they are far. For that of the linear regression, we'll just see a line from here to this of the 20,000. Yeah, was performing really poorly, but for decision tree regressor perfectly fit it really well. All the points, all the data was able to predict it, all of them really well. So I think with this, we have come to the end of the video on how to actually make use of this of the decision tree regressor and this of the decision tree classifier. These two guys, they are decision tree based model on this of the scikit-learn. So any one of your choice you want to actually make use of. So make sure when you're using a regressor, use it on that of the linear type of, a regression program. When you're using a classifier, use it in a classification program. Yeah, that's just basically simple to that. Linear for linear and classifier to classifier. Classifier or linear or classifier can be might naturally perform when it was being used on the right data. So I think this concludes it for this video. If you find this video anywhere useful, subscribing is not going to be a problem. So I'll be happy to see you in the next video. Thank you for watching.